Technical theater students are working on set pieces for the school musical. They plan to use several set pieces based on the plan shown below. Some will be used to hold props, others will be risers for actors to stand on while they sing, and a few will be large raised stages for dance and chorus members. Use the table of values to write polynomial functions for the volume of each set piece in terms of its width x, and use the functions you generate to show that the total volume of the set piece is the sum of the volume of each set piece. If two theater technicians work together and one builds a bottom portion that has a volume of 171.5 cubic feet, what will be the volume of the top portion of the set piece that the other theater technician must build? Justify your answer. Okay, so we're going to use these tables of values to find equations for the bottom portion, which just this bottom portion, this rectangular prism, and then find an equation for the top portion and add those equations together and see if they match the equation that we get from finite differences from the table of the total volume, if that makes sense. So basically, we just want to verify that each of these equations, we're going to come up with equations for the data points and just make sure that the two volumes of the two rectangular prisms will add together to be the total. And then we'll go ahead and find the real life situation there. So I've gone ahead and I've split up these tables so that we can find the equations. Now that we have these tables split up, then we can go ahead and find the finite differences. So 87.5 minus 56 is 31.5. And then subtracting the rest, 56 minus 31.5 is 24.5. And then similarly, we get 17.5 and 10.5. And so we see it's not linear. None of those are constant. And just something to note here, on the other page, then these x values are 1, 2, 3, 4, and 5. And so these are constant delta x of 1. And so that's important to note. And then let's go ahead and find the second difference. So 31.5 minus 24.5 is 7. And similarly, we get 7 for the other two. So this is going to be a quadratic function because the second difference is the same. And so if we remember our rules from chapter 1, then we know that 2a equals the second difference, which is 7. So then dividing by 2 on each side, then we get a equals 7 halves, or 3.5. And then we know a plus b is the first difference between x equals 0 and x equals 1. And notice we don't have that value. We need to know what x equals 0 is, or we can work backwards using our differences. And so if we know that the second difference has to be 7, then 10.5 minus 7 would give us 3.5 for the first difference there. And so that would give us the first difference. So if a plus b is 3.5, then we know that a is 3.5 plus b equals 3.5. So we can subtract 3.5 from each side, and b would equal 0. So there's that. And then we also need the c value, which is the y-intercept. And so if the first difference there is 3.5, we know that when x equals 1, 3.5, that needs to be 3.5 away from whatever the y value is at x equals 0. So 3.5 minus 3.5, that's just 0. And that makes sense because the volume of the bottom portion, if it's 0 feet, it's not going to have a volume. It'll have a volume of 0. So I'm just going to make a note on each of these that the y-intercept on all of these will be 0, just because for volume, if you plug in 0 feet, you're going to have 0. So let's go ahead and write out the equation for b of x. So b of x will equal, so it's ax squared. So a is 3.5 x squared, and then plus bx plus c, well, b is 0 and c is 0. And so the other terms will just be 0. So that is our final equation for b of x. So then continuing on, then 35 minus 24, we get 11. 24 minus 15 is 9. 15 minus 8 is 7, and 8 minus 3 is 5. So again, it's not linear. Let's keep going. So 11 minus 9 is 2, and similarly, these other ones are 2. So again, we have the second difference in common, and so we can use these same formulas that we used before. We know that 2a equals 2, so dividing by 2 on each side. And then using for b, we know a plus b equals the first difference. So to find the first difference, we can work backwards. We know 5 minus 2 will equal the first difference there. So that's going to be 3. And so a plus b is 3. If a is 1, then looks like b will have to be 2 to make this work. So b equals 2. Again, we saw before that c is going to be 0. since when the feet are 0, then the volume has to be 0. So we can go ahead and write this out. So T of x will equal 1x squared, or just x squared, plus bx squared, or 2x, sorry, just bx, so 2x, and then c is just 0, so we don't need to write that part. So we have our T of x function. And then let's go ahead and find the last one. So 22.5 minus 80 is 42.5. And then subtracting the others in that same order. Again, it's not going to be linear, so let's keep going. So subtracting 42.5 minus 33.5, we get 9. And then doing the other two, we also get 9. So again, it's a quadratic function, so we know that 2a will be equal to the second difference, 9. And then dividing by 2 on each side, we get a equals 9 halves, which is the same thing as 4.5. And then for b, we know a plus b equals the first difference. So we need to work backward to get between x equals 0 and x equals 1. And so we know that 15.5 will have to have a difference of 9 with the first difference. So 15.5 minus 9 will give us 6.5. And then a is 4.5. So then subtracting 4.5 on each side. So b equals 2. So then our function for v of x will be ax squared, so 4.5 x squared, plus bx, so 2x, plus c, which is 0. So there is our function. And now we can go ahead and just double check and make sure that these do all add together. So we want to know, is b of x plus t of x equal to v of x? So b of x here is 3.5 x squared, and then t of x is x squared plus 2x. So adding these together, 3.5 x squared plus 1x squared will give us 4.5 x squared, and then we still have plus 2x. So we see it does equal what we found, so that is a great sign showing that the two do add together and that we found those equations correctly. And so now let's go ahead and answer the last part of this problem. So in the last part, it tells us that the bottom portion of the cube will be 171.5 cubic feet. And we know that b of x is equal to 3.5 x squared. And so we can go ahead and just substitute 171.5 into this to see what the foot value is, because we really can't find the top portion until we know what x will be. And so if we substitute that in, then we can go ahead and our first step to isolate x would be dividing by 3.5. And so 171.5 divided by 3.5 is 49 equals x squared. Taking the square root on each side, then we get 7 equals x. And so now we can use this to plug into our t of x, which is the top portion. The equation that we found was x squared plus 2x. And so if we go ahead and plug in 7, then we can find what the volume is for the top. So 7 squared is 49, plus 2 times 7 is 14. So 49 plus 14 is 63. And that will be feet cubed, or cubic feet. Go ahead and summarize our answer. b of x equals 3.5 x squared, t of x equals x squared plus 2x, and v of x equals 4.5 x squared plus 2x. b of x plus t of x equals 3.5 x squared plus x squared plus 2x equals 4.5 x squared plus 2x equals v of x. Therefore, v of x equals b of x plus t of x. The volume of the top portion of the set piece that the other theater technician must build is 63 cubic feet.